I'm Micah Smith, and this is AAillustrates. This session, we're going to be looking at intelligent automation, and I'm super excited for this session because we're going to be building something that you're going to be able to build along with me that's going to do something that I think is really impressive, and it's going to be a really fun session. So hang with me through the whole thing. First off, what is AAillustrates? AAillustrates is an episodic series where we answer questions from those who are interested in robotic process automation and specifically with Automation Anywhere. And so we create this content so that you have different ways you can get hands-on with our products. Most of them are demonstrations. Most of them are really hands-on, tangible. You get the code, you get to see exactly what we're doing. And so if you want to use these as an opportunity to learn and build along with me, that's exactly the point. But we want to hear from you. So what is the content that you want to see? What's the content that you like? What's the content that you want to see less of? Let us know. You can reach out to us on Twitter. You can leave comments on our YouTube channel, or you can leave feedback on our LinkedIn page as well. So get in touch with us on social, and we'll be sure to cover the content that you're interested in seeing. So for this week, like I mentioned, we're going to be looking at intelligent automation, and we're going to talk about what is intelligent automation. And you might have heard this phrase before, and you might have heard it called like cognitive automation. I'll probably use those terms interchangeably during this session just because I'll forget what we called it or whatever. But we're going to break down like what is intelligent automation or what is cognitive automation. And then we're going to do a deep dive and we're going to do a sample bot. And I promise you're going to build a really cool bot if you hang with us through this whole thing. So we're going to look at a problem statement. We're going to talk about some potential solutions or ways that you might try to solve such a problem. And then we're going to do the full intelligent bot build. And so you're going to want to hang with us through that because we're going to introduce a tool here that's going to allow you to build that. And it's really fun, I promise you. I spent a ton of time on this one. All of that said, this could get to be a long session, so we might cut this in two. I'm not sure yet, but hang with us. You're going to enjoy it. I promise you're going to learn something. So first off, what is intelligent automation? So I'm going to go with this definition here and then we'll break it down a little bit. But intelligent automation is a combination of robotic process automation and artificial intelligence technologies, which together empower rapid end-to-end business process automation and accelerate digital transformation. So that's a good definition. It's pretty marketing heavy. Here's how I would visually show what intelligent automation is. So first, on the left side of our Venn diagram that we're going to build here, we have RPA. And RPA I would describe as task-centric, rule-based automation across APIs and GUIs, right? So RPA bots, as you may be familiar with, are able to automate across the user interface of an application. So if that means like, hey, clicking buttons and filling text into fields and things like that, it can do all of that. But it also allows me to interface with APIs. So if I need to call an API to validate data or to do some kind of lookup or to give me some information, I can do both of those things, right? And so it allows me to work across APIs and across GUIs. On the other side, we have AI, and I'm using AI as a very, very broad categorization here. But essentially what I would describe as artificial intelligence is data-driven modeling mimicking cognitive decision-making, right? I made both of these definitions up. If you don't like them, blame me. But think about what we're saying here, right? When Netflix recommends a certain movie to you, or when you're driving in a car that has automatic steering, right? How is all of that happening? Well, it's data that's being used to mimic decisions that humans would otherwise make, right? So take Netflix, for example. When it makes a recommendation to you based on the stuff that you've previously liked, it's the same thing as one of your friends who, you told all your movies to that you really like, and they happen to know a movie that has some of the same actors, is the same genre that you might also like, and they would recommend that to you, right? It's the same kind of thing. So when we think about AI, what we're thinking about is taking lots of data, trying to use that data to drive or mimic human decision making or cognitive decision making. And that kind of sweet spot in between the two of those is where we have intelligent automation. And that's where we're taking the benefits of RPA and we're using the benefits of artificial intelligence, remember, to mimic that cognitive decision making to create intelligent automation. Let's look at some applications of that. And you may have seen some already and you may be familiar with some of these, but let's look at a couple applications of this and then we'll get into a real use case. So the first example that I think of when I think of intelligent automation is intelligent data extraction. right? And IQbot is a great example of that. And there's a couple angles to that. The first, I would say, is being able to do that OCR, right? And the OCR itself is not necessarily a super straightforward process. When we talk about taking an image and trying to recognize the characters of that image as text, right? That in itself is trying to do that same thing, right? Mimicking that cognitive decision making that a human would do. Second, when we're talking about an IQbot, we're talking about not only doing an OCR, not only trying to do optical character recognition and read the characters from that form, but we have to be concerned with the relationship between those different characters and those different fields. And not only knowing, how to read data from the form, but what data do we need to read? What data relationships exist? And how do I make sure that I'm reading the data that I actually care about, right? All of those to me represent intelligent automation. So when I see the word date and right next to it is a date, right? How do we have that association where we're automatically extracting that piece of data and we're looking for that kind of anchor to tell us where the data is that we're concerned with? The next example I look at for intelligent automation is process discovery and bot builds. So when we look at Discovery Bot, with Discovery Bot, you have the ability to do recordings, and you can do recordings based off of different, tasks or different automations that you're trying to build. And you can have someone do a recording, and you can do a recording, and then I can do a recording, and someone else can do a recording. And we might be doing the same process, but we might do it in slightly different ways, right? Maybe I happen to know the shorthand keystroke, and you happen to just click in the menu items to do it, right? We're doing the same task, but we're doing it in lots of different ways. When we combine those with Discovery Bot, we're looking to create a single process or a single bot off of that, right? And that's where we're starting to do some of that intelligent automation. So not only are we doing the recording, but we're also creating a bot as an output of those different recordings and trying to, identify where the similarities are, where the differences are, and then having basically a bot that automatically builds another bot. And that would be our intelligent automation. The next integration that I think of for intelligent automation is really determining where and when and how to trigger our different bots. And this is something that not a ton of organizations have got to, but this is where I would look at like chatbot integration, right? So if the front end of my ability to trigger bots is through chatbot, that chatbot is going to be asking for things like, hey, what kind of bot actually needs to run? And it's probably not going to use that language, right? We're probably going to use natural language to try to ask the questions to figure out what bot needs to run, maybe what data that we also need to pass to that bot. And so determining what bot and when a bot or if a bot should be triggered is intelligent automation, right? That's where we're using some intelligence on the front end to determine what data do we need, how do we get that data to the bot, and how do we actually trigger the bot directly from that chat integration. That's another example of intelligent automation. And then the final thing I would talk about here is directly from within our bot. And if you've used any of the bot store packages from A2019, you've seen that there are some kind of more intelligent automation packages that are available in bot store. So when we think of things like the Microsoft Lewis NLP integration, right? I can make a call out to another cognitive service directly from within my bot. And maybe that's to analyze text. Maybe that's to analyze an image, right? Maybe I have like these pictures and I need to classify them, and I call this cognitive service from Azure, or I call some cognitive service from Google. I do have the ability to integrate with those different cognitive services, third-party services, something I've written myself, directly from RPA. And again, that's where I'm starting to have that intelligent automation within my process. What other examples could there be, right? What else could we do directly from within our bot? And we're going to look at a new example of that in a category that I haven't totally covered here in just a minute. So as a part of our deep dive, we kind of covered what is intelligent automation. I want to look at a, kind of a real use case and talk about how we might solve that, and then we'll get into actually building a solution for this. So let's take an example that we're likely all somewhat familiar with, which is like an IT help desk, right? The bot will monitor a single inbox, which gets emails from employees asking for assistance from IT. So this is a problem that we're all pretty familiar with, right? I need some kind of IT help. Either it's hey, I need some software installed, or hey, my printer's not working, or I can't get on the Wi-Fi. So what do? Well, we would send an email to the kind of generic IT help desk email address at our organization, and we would say, hey, I need the following help. From there, what's likely happening, and again, this is going to be dependent on your organization, but play with me here. So someone on that help desk team then has to read what you sent as an email, and then they would try to understand what you're trying to get at or what help you need, and then they're sending that to the appropriate group. So that might be to the networking group because you need help with your Wi-Fi, or it might be to the desktop hardware team because your monitor's not working, or it might be to the desktop software team because you need something installed, right? So they're playing that sorting and making sure that it gets to the right groups and the right teams and the right individuals based on the text of the email that you send, right? So we're going to try and create a bot that can do that exact same thing. So based on the language and exactly how you phrased it and how you set up that email, the bot will need to forward the request along with the email to the appropriate IT group. So we're going to, for our example, look at desktop hardware, desktop software, networking, account access, and general questions, right? So our goal is to say, of those 5 different categorizations, how do we build a bot that's able to automatically classify the incoming email to one of these different groups, send that email to that group, and then reply back to you letting you know, hey, we got your email, someone from the desktop hardware team is going to look into it, right? So that's the bot that we're going to try to build, and that's the use case that we're going to try and tackle here. How do we automatically sort these incoming emails even when everyone is using their own crazy language, however you write that you have a printer issue, or maybe you can't describe it really well because you don't know all the technical stuff that's going on, but hey, I just know that I have a blue screen when I turn my computer on. So we're going to try and figure out if we can write a bot to do that. So let's talk about some possible approaches to that, right? When your boss comes to you and says, hey, this is the bot we need to build, the first thing that I'm going to do is I'm going to try and brainstorm all right, what are the different ways that I could solve such a problem? And so this is just the first things that came to my mind. So first, obviously, we could just have a human monitor the inbox and forward them to the appropriate group, right? That's the easiest way. That's the way it's been done forever, right? And obviously that works. But it does require someone to sit there and monitor that inbox when they could be helping other employees or helping other customers, or they could be doing something totally different, right? So does it make sense to really have a human doing that? I don't know. The second thing that comes to mind is we could make everyone use like a predefined email template and hope that they know how to classify their own problems, right? And so maybe we have this email template and it's, like a little table and it says, what's the classification type? And, we could even have drop downs for them and try to let them classify them on their own. I don't know about you, but if you've ever worked in one of those systems or worked with something similar to this, right? Whether it's a web form or an email, for me, a lot of times I'll look at the drop down and I'll say, well, mine doesn't really classify into one of those. I just needed to go to this one group and I don't know how they classified it or how they used that, right? So that can work, but again, it requires that someone have that original template, and it would require that our bot knows exactly how to read that table as it comes in, right? So if the table is really simple and it just says like what group you work for, what classification you think your ticket is, and then what's the problem, the bot could try to read that from the email, and obviously that would come through as a table. Likely we would use that as like an HTML email. We would read that. We could probably get to it that way. But again, it's going to require everyone to have that template, and that's kind of like not a super luxurious process. The next idea, we could try to just search for specific keywords and classify accordingly, right? So if you said anything about monitor, we're going to assume that that's a desktop hardware problem. And if you said anything about printer, same thing. Or if you said Wi-Fi, we're going to classify that as a networking issue, right? That would maybe work. I feel like you would be infinitely chasing down new keywords or new combination of keywords to try to create different rules for. And I feel like it would be a mess after a while. So that might work for some really simple examples, but when someone gets to actually trying to describe their own problem, you might find that people use language differently or things like that, and that could fall short. The fourth example is to create a machine learning model based on previously classified tickets and use that to attempt to classify new tickets accordingly. Okay, so spoiler alert, that's the one we're going to try and do for this particular episode. We're going to see if we can create a machine learning model that's going to allow us to classify tickets, right? We're going to take some data, just like we talked about with that data-driven decision making, right? We're going to take some data of classified tickets and see how we can make predictions about new emails that are coming in so that we can hopefully send those to the appropriate group. So let's talk about exactly what's required for that and how we might do it. So first off, if we're going to try to do this ticket classification based on text, we're going to need a sample, and preferably large, right? The more data, the better, of tickets that have already been pre-classified. So we need examples of those desktop hardware emails. We need examples of those desktop software emails and the network, what do we call it? Yeah, networking and account access and general questions. We need examples of all of those types, right? And we need lots of them because the language that I use may not be the exact same language that you use or that the person sitting next to you uses, right? And so we need to make sure that we have a really representative sample of lots of different people using the natural language that they would use to get help that they need, right? And we want tickets, or we want, those emails that have already been pre-classified because we're trying to train a model here. And so when we train that model, we need to tell it like, hey, when you see this, this particular email, this is an example of a network issue, or this is an example of account access issue. So we would need that kind of data. Next, we'll need to sort them by their type so we know how many of each subset exist. Okay, so let's say that I got 1,000 samples, but if 900 of them are of account access problems, well, I have a really small set then of the desktop hardware and desktop software. So what we want to do is, for our 5 classifications, we want to take all of the samples that we have and we want to classify them by their types and say, hey, show me all of those for desktop hardware, right? And I want to see how many of the desktop hardware I have versus how many I have for desktop software and account access and networking, because I need to take a sample of each of those samples to create what's called my test set. So I need to create a test data set and a train data set. Okay. Now, the reason I do that is because when I'm actually training my model, I need to give it some data to train off of, and then I need to give it some data to test off of to validate how accurate the model is, right? So I'm going to give it that train data set. That's what it's going to learn off of. Then I'm also going to give it a test data set, and that's what it's going to validate itself off of to know how accurate its predictions are. From there, we create a machine learning model based on that train and test set. Okay. Now, if you don't have any background in machine learning and this is all like totally foreign to you, please don't disconnect right now, right? I worked together with a friend of mine to create an application that's going to allow you to do all of this, right? And it's really fun to use and it's really cool, and I promise you'll be able to figure it out. So let's have a call now with Harish, and he's going to introduce this tool that we created. Okay. So I'm joined by Harish Mehta. Harish, would you want to introduce yourself?
Oh, yeah, sure. Yeah, hi, my name is Harish Mehta. I work for Cognizant and as an architect. Most of my experience is in Captiva, .NET, RPA technology.
Very cool. So Harish and I go way back, and Harish helped me out with an application here that we're going to use for our cognitive automation, intelligent automation use case. So I'm going to share my screen and we'll let Harish introduce this application and kind of walk through exactly how it works and what it does. So Harish, go ahead.
Yeah, sure. So this is a very simple application which is using ML.NET for classification. So there are 2 tabs here, which is get doc type. Pretty much, we will give the input to this, and it is to consume the model, okay? And there's another tab to build the model where we will pass our training data, test data, and behind the scene logic will build our model.
Okay.
So let's test it.
Okay, so I think, so right here, what we'll do, I have a test and a train data set that you sent me. This is for ham spam classification, and I know this is a very popular data set for kind of learning machine learning for developers. But what we'll do is I'm going to put in the train data set right here, and then we'll put in the test data set on this side. And I'll just real quickly show one of these so we can see exactly what we're looking at. But it's we have two columns. There are really two fields, right? There's type and then message. And so for each one of these are messages that are classified as ham, or basically the opposite of spam, right? So these are real text messages. The ones down here are spam text messages. And so the idea with this is that you would build a machine learning model that's able to appropriately classify whether a message was a spam message or not. So the last thing it looks like we'll give a model location. I'm just going to save the model right here. Okay. And then we'll hit build model. So Harish, talk to us just real quick about what's going on in the background right now.
So in the background, what system is doing is that, okay, it is taking this trained data and we have an algorithm defined that, okay, which algorithm it should use it. So pretty much the data we are passing it to that algorithm, and that algorithm is building our model. And in the same continuity, what we are doing is we have a test data, and the test data we are passing it to our model, and that model is testing it, the accuracy, and then it's showing the accuracy as a model accuracy is at 95%. So that's like behind the scene, it happened, which is like build the model and test it. So our test data is for model accuracy.
Okay, cool. So let's, I'm going to switch to the consume tab, and let's take a look to see how this works. So I'm going to put in the location of our model, and that's just going to be model.zip. And again, it's just the same folder right here. And then text to classify. So if we said, like, if we got a text that said, congratulations, you just won oops, let me spell this right. You just won $10,000 in a foreign lottery. Respond. Man, I can't type. Respond now to claim your winnings. Right? So to me, that seems like a pretty spammy message that you might get. If I hit classify, we can see that the model says that this is 95% sure it's a spam message. On the other hand, let's fill in let's say, hey, Harish, this is Micah. I got your text. Right? That's a message that's not spam. That's one that I would actually send to Harish. And in this case, the model is 97% sure that that's ham, right? Not a spam message. So what we're going to do is we're going to try and take this application, and we're going to try to build our own model based off of the IT help desk classification problem that we introduced already, and see if we can build a bot that will automatically classify emails. Harish, thanks so much for your time. Thanks for helping out with this call.
Okay.
We'll see you later.
Okay, thank you.
Right,
bye-bye.
Okay, so we're actually running a bit long on time here. So what I'm going to do is we're going to end the session now, and then we're going to pick up with next week's session. And in next week, we'll actually take the application that Harish and I just looked at, and we'll talk about how we can build our own model using that application for the IT help desk situation. And then we'll build a bot that actually consumes that model and will automatically try to classify those emails that are intended for help desk. So I know this is like super anticlimactic because we just got off with Harish, and now we see what we have, and we can finally start to see how we can build this model. But the bot build session itself is going to take at least about a half hour. So I want to make sure that we're not making this session too long. Make sure to come back for the next session. All of the code that Harish and I just looked at is going to be made available on GitHub. So you'll have that same application that Harish and I were just testing with. You'll be able to create the same bot. You can run the app however you want. You can tweak it if you need to. You'll have all of that code. So it's going to be really exciting to be able to give that out for everyone, but you need to come back for the next session. So this is the end of Intelligent Automation Part 1. Come back next week for Intelligent Automation Part 2, where we'll give out that code and we will finish with our bot build. My name is Micah Smith, and this has been AA Illustrates. Go be great.